Hi everyone, today we're going to discuss using law of cosines to solve for missing pieces of a triangle, either angles or sides. Here's the formula for law of cosines. It will be given to you on the reference sheet so you won't have to memorize it. We use law of cosines when we have three sides and an angle. And here's the formula, like I said, where A is the included angle. So A is the only angle. A, B, and C here are all lowercase letters, so those are sides, and an uppercase letter is an angle. So therefore, we have a whole bunch of sides and one angle. So let's do this by example. Let's look at example number 1. Example number 1 gives you a triangle, ABC, where little b is 12, little c is 20, and the measure of angle A is 40 degrees. Now in here it says 45, here it says 40. Let's just change that to 40, just what the given problem is. And it says find side A to the nearest integer. So let's write down the law of cosines formula. So we have a squared equals b squared plus c squared minus 2bc cosine A. So we want to find A, so a squared stays. What is b? B is 12. So plug in with parentheses. What is c? 20. And 2. B is 12, C is 20, and cosine of A. What's A? A is 40. So we want to find A squared. So all we have to do is plug this whole piece into the calculator. Let's do that. So parentheses 12, close parentheses squared, plus open parentheses 20, close parentheses squared, minus 2 parentheses 12, parentheses 20, cosine 40, close. Hit enter. You should get that A is about 176.298. And then, I'm sorry, that's A squared. Then we need to take the square root to get A by itself. So second square root, second answer, you get that A is about 13.2, but it says round to the nearest integer, so about 13. So that was pretty easy, right? Plugging it into the formula. Okay, well now what becomes tricky with law of cosines is that I could change the problem and ask you, so look at example number 2. It says in triangle ABC, A is 3, B is 5, C is 7. What is the measure of angle C? So in this formula up here, there's no angle C. So what you're going to do is you're going to replace the A with C. And what would you have to replace over here? Side C. And then everywhere you see a C, you'd have to change it. So let's go through this slower, and let's draw a picture. So we've got triangle A, B, C. Little a is 3, little b is 5, and little c is 7. They want to know what is the measure of angle C. So this is your unknown. So I want you to think of law of cosines, the formula, as whatever angle they give you is here, has to match here. So that's where you're going to start. And then everything else falls into place. So we're going to start with 7, and we're going to square it. So 7 squared, because that's my C, equals, now do the other two sides, 5 squared plus 3 squared minus 2 times 5 times 3 times cosine of C. Now we're not going to solve it. I just wanted you to practice manipulating the formula. Let's try another problem. So again, we've got triangle DEF, so we can go ahead and draw a picture. So triangle DEF. They say D is radical 3, E is 4, F is 30. They want to know the length of side F. So again, isolate the angle that's given. So since the 30 is given here, the formula is going to have at the end cosine of the 30, the only angle that's given. So what needs to go on the other side? F. So F squared. And then you just take the other two sides and square them. So 4 squared plus radical 3 squared minus 2 times 4 times radical 3, and then cosine of 30. So this is how we would set them up. Okay, let's try example 3. So it says find the largest angle to the nearest tenth of a degree. Well, where do we know the largest angle is? Well, from geometry, we should remember that the largest side is across from the largest angle. So therefore, the largest angle here is B, and that's what I want to solve for. So again, when we set up the law of cosines formula, the B is the angle that's given, or what we want to find. So the formula is going to have cosine of B at the end of it, and then what's going to go on this side? The 18, the angle that's opposite the side. So 18 goes here, 18 squared, equals, now we take the other two sides and square them. So 9 squared plus 12 squared minus 2, 9, 12. Okay, now we have some solving to do. We'd like to solve for B. So we can't put this all into the calculator like the first example. We have to do some simplifying. So in the calculator, do 18 squared. You get 324. And let's do 9 squared. You get 81. And 12 squared, you get 144. And then minus, let's find this product. 9 times 2 times 12. You get 216. Now, a lot of you are probably thinking that you can add all three of these pieces together, but you can't because this 216 is attached to the cosine of B. So for example, if I had 81 plus 144 minus 2x, would I add all of this stuff and then tack on an x at the end of it? No. So we're not going to do that same thing here. So let's add the 81 and the 144. That we can do. And you'll get 225 minus 216 cos B equals 324. Now, again, can I add these two? Can I add, if it were 225 minus 216x, could I add those two and put an x at the end? The answer is no. So, we have to subtract the 225 on both sides. So, in the calculator, 324 minus 225, you get 99. So 99 is equal to negative 216 cos B. How do I get B by itself? Divide by negative 216. So 99 divided by negative 216, you get negative 0.4583. So cosine of B is equal to negative 0.4583 ... How do I find angle B? Remember, you can't put the negative in, so it's cos negative 1 of negative answer. You got to negate the answer to make it positive. So second cos, negative second answer. And you get that B is about 63 degrees. Okay, so what do I know about cosine? We know that cosine is negative. So what quadrant am I in? Well, A, S, T, C, we are here and here. So for quadrant 2, it would be 180 minus 63. And we would get 117. And for quadrant 3, it would be 180 plus 63, which is 243. Now, if you look at these two angles, is it possible for one angle of a triangle to be 240 degrees? No, because you can only have three angles add up to 180. So this one does not exist at all. You can't even use that one. So it's just 117 is my final answer for B. Okay, next example. I can use law of cosines in parallelograms. So in example number 3, they give you a picture of a parallelogram and they want to know the diagonal. So we have this picture here. So let's isolate our eye just on this bottom triangle and think about law of cosines. So law of cosines says if I have three sides, 1, 2, 3, and an angle, I can use it. Now remember, the angle that's given is going to go at the end of the problem. So cos 116. And then what goes over here on the left-hand side? The angle or the side opposite it. So this would be b squared. And then we're just going to plug in the 40 squared and the 22 squared. and subtract 2, 40, and 22. And now this one's nice because I could just throw this whole thing into the calculator. So let's do that. You should be getting 2,855.53321 ... So just take the square root, so second x squared, second answer, and we get that b is equal to 53 degrees. Or, I'm sorry, not degrees, that b is equal to just 53. We're finding a segment. Okay, so example number 4, I want you to try for homework, but I want to set you up for it. So it says in parallelogram A, B, C, D. So let's go ahead and draw that. So A, B, C, D. It doesn't matter where you start as long as you go clockwork. And it says AB is 240, AD is 450, and diagonal AC is 290. What is the measure of angle BCD? So BCD is this angle right here. So let's focus our attention on, I don't know, the top or bottom triangle. It doesn't matter. I like the bottom, so let's just do the bottom triangle. And we know that if this side is 240 over here, what would this side be over here? 240. So look at this triangle that we've got here that I've highlighted in blue. I've got 3 sides and an angle. But which angle? We're not going to use this one in here because this would be the whole angle that I want to find. And if I find this, I can't just double it. It doesn't work like that. So maybe what we could do is find this angle here. So we'll call this the angle X, and that's the angle you want to find first. Why? Because if I know this, how do I know this one? So for example, say that X is 100 degrees. What is this whole thing here? You should be telling me 80, because in a parallelogram, consecutive angles add up to 180 degrees. So again, our goal for this problem is to use this bottom triangle, find X, and then subtract it from 180 to get this whole piece. If you have trouble, we'll definitely discuss it in class tomorrow. All right, good luck.